Okay, so the question we're going to be answering today is use the definition of continuity on a closed interval to discuss the continuity of f of x is equal to 1 over x squared minus 9 on the closed interval of 0, 3. So first we're going to talk a little bit about continuity, what that is. That basically means being continuous. So I'm going to give you a quick example of a continuous function. I'm just going to draw a parabola. So this would be considered continuous, and that is because as I'm drawing the graph, I did not have to lift my pencil at all. It just went straight through, no holes or gaps. So this is continuous. Excuse my sloppy writing. There are also what we call two forms of discontinuity. The first one I'll mention is a removable discontinuity. So that is, let's say that this is x equals 2, and we're just going to use another parabola. As we're drawing our parabola, we have to stop and pick up our pencil and continue on. So this would happen at this case. That means that x equal to 2 is undefined, so the graph cannot go through that part. So this little hole here, it makes it so that we have to jump. It's not continuous anymore. However, the reason it's called removable is because you can actually redefine your function and color that in, which no longer makes it discontinuous because you can go straight through now. So it's now continuous, and that is what we call removable discontinuity. The second type of discontinuity is a non-removable discontinuity. And that is when you have basically like a gap that no matter what you do, if you refine your function, it's not going to matter. You're not going to be able to fill in that gap. So an example of that would be, we'll make this x equals 2 again. And then we'll just put the graph going through here. And then this one coming in over here. No matter what you do to your function, you're not going to be able to fill that in. So it is non-removable, and that's the second type of discontinuity. So when we look at our problem, at our function, which is f of x is equal to 1 over x squared minus 9 on the closed interval of 0, 3, basically what the question is asking us to do is to tell them whether or not this is continuous or not at this interval. So, well, hopefully the first thing that you see that you can do here is that you can factor x squared minus 9. So we actually have f of x is equal to 1 over quantity x plus 3, quantity x minus 3 on the closed interval of 0, 3. So the first thing that I notice is we cannot have a denominator that is equal to 0. That makes the entire thing undefined. So using the zero product property, which states that if you have a plus b plus c is equal to 0, then each of them, a, b, and c, is individually equal to 0. So we know that we have x plus 3 is equal to 0, x minus 3 equal to 0. In turn, we have x is equal to negative 3, and x is equal to 3. So these are our vertical asymptotes. So I'm just going to draw out this graph really quickly. If you have a graphing calculator and you're able to use it, that is definitely a big help because it'll be able to show you your graph. So we have the vertical asymptote at negative 3 and at 3. And then our graph is going to look something like this. Okay. So the part that we are interested in is this interval here from 3 to negative 3. So the first thing that we need to look at is f continuous on this interval. And if you look, you can see that as we are drawing straight through, there's no discontinuities, there's no gaps or holes, so the answer to this question is yes. So the second thing that we're going to do is we need to, we're going to plug in both of our 0 and our 3 into the function separately and see if there's going to be any domain issues, if we're going to have any problems with that. So we'll start with 0. So this is going to be the limit as x approaches 0. And in this case, we want to see if this interval is going to have any discontinuities. So we're going to be approaching 0 from the right, and we're going to be approaching 3 from the left. So from the right, so we have the plus symbol of 1 over 0 squared minus 9. And this is going to give us 1 over negative 9. And actually, I get myself in trouble here. This has to be x squared. It's only when you actually plug in the 0 that you can drop the limit. But if the limit's there, then it has to be x. Otherwise, it's considered wrong. So that was my mistake. As we can see, there's no problems here. It's not undefined. So coming from the right, going towards 0, there's no discontinuity, and 0 is going to be included. So the second part that we're going to do is with number 3, so that'll be the limit as x approaches 3 from the left of 1 over x squared minus 9, which is equal to 1 over 3 squared minus 9. So as you can see, this is going to be 1 over 9 minus 9. That's kind of not going to work out because it's 1 over 0. Makes it undefined. So that means, and that's kind of implied when we have the vertical asymptote at 3, it will get close to 3, and it'll get as close as it possibly can, but it will never touch 3. So we know that at 3, it'll get all the way up to 3, but it will not include 3. So this is going to be parentheses. So we can conclude, based off of the definition of continuity, that f is continuous on the closed interval. Well, I guess I shouldn't say closed because it's not completely closed, but of 0, 3, where 0 is included and 3 is not.